Today I want to review with you naming and formula writing for simple ionic compounds. An ionic compound consists of a metal and a nonmetal. So basically what happens is the metal donates the electron to the nonmetal. So here's our metal right here, lithium. It's going to donate its one electron over to the fluorine. And what results is a positive lithium right here, and you have a negative fluorine over here. So lithium loses one, fluorine gains one, and they are held together by an electrostatic attraction. That's the positive and negative charges that's holding them together. So the compound becomes electrically neutral. The positive charges equal the negative charges. And here it's pretty simple because you have a +1 and a -1, so they start out equal, so it's very easy to balance it. Now that we know we're working with ionic compounds, we want to figure out how to write the formulas and names for these compounds. Very important in chemistry. So the first part will be, when given the formula, how do we write the name? That's actually much easier. So if we want to take our formula, CaF2, the first thing we always want to do is make sure it's ionic. And we do that by checking to see if we have a metal and a nonmetal. So calcium is on the left side of the periodic table. It's a metal. Fluorine is on that upper right corner. That's a nonmetal. So yes, we have an ionic compound, so we can go ahead. The next step is to write the name of the metal just the way it is. Calcium, straight from the periodic table, is just written as calcium. After that, we're going to write the name of the nonmetal, but the thing is, we're actually going to change the ending to IDE. So we start out with fluorine. We're going to change that ending to IDE, so we're actually going to write down fluoride. The second element in any compound always takes an IDE ending, unless it's a polyatomic, which we'll get to later. So the name of our compound, CaF2, is calcium fluoride. Okay, now, a little bit harder to do is to write the formula when they're given the name. And the reason it's a little bit harder is that we need to balance the charges of those ions to get that electrically neutral compound. So again, step one is always the same to make sure it's ionic. Here, again, magnesium is a metal. It's on the left side of the periodic table. Iodine is a nonmetal. It's in the upper right-hand corner. So yes, we know it's ionic, so we can proceed. Second step, we want to write the symbol and the charge for each element, but we want to keep the order that it's written in. So magnesium is going to be Mg. Now the charge is going to come from the group number. Metals have a plus charge, and it's always equal to the same as the group number. You reviewed that already in one of the previous slides. Iodine is going to be a negative anion, and it's in group 7, so it's going to form a -1 charge. Now, step 3. Use the crisscross method to balance the charges of the cation and the anion and create an electrically neutral compound. So here's where we need to do a little bit of math. So magnesium starts out as a +2. It has 2 electrons it wants to give away. Iodine can only take 1. So in order to get everybody with a full shell and not leave any electrons hanging around, we need to add a second iodine. And the way we know that is by a shortcut method called the crisscross method. Here, we take the charge, not the sign, just the charge of the metal, drop it down, and that tells us how many atoms of the nonmetal we're going to need. So that says we need 2 atoms of iodine to balance that charge. Now on the flip side, we do the same thing over here, except now what we want to do is we want to just look at this 1. There's nothing written here, so we know it's an unwritten 1. We drop that down, and that becomes the number of metal atoms that we need. So magnesium needs a 1. Now we know in chemistry that most of the time these 1s aren't written as coefficients or subscripts, so we can go ahead and erase it right away. Now we've created a formula, MgI2. So let's go ahead and check to see if we actually have an electrically neutral compound. We start out with 1, 2 plus charge, and then we added to it 2, 1 minus charge. That's 2 iodines. So the magnesium was a +2. We had 2 -1 iodines. So that gives us 2 plus, +2 minus, balance out. There's your electrically neutral compound. So your official formula for magnesium iodide is MgI2.